Okay, so any question you have?
No, not really.
Okay.
Thanks.
So yesterday I was discussing about this logistic regression model, right? So this is the logistic regression model. Okay, that means here you have this probability. So what is this probability? So P is probability of occurrence of the event Y.
Mm-hmm.
Okay, so here this so from this logistic regression model we derive this sigmoid function, right? So P
Yep.
equals to 1 upon 1 plus e to the power of minus this term, right hand side term. So this is my sigmoid function. Okay, now here so this is a sigmoid function, or I can say a S-shaped curve. So we have seen this curve here. Now let's say here if I just draw this. So in the x-axis I have this independent variable,
Mm-hmm.
okay, x, and in the y-axis, so it's a categorical variable, right? So y is either 0 or 1. Okay, so for example, let's say I take this example like y equals to 1 means that the customer will buy that particular magazine. Y equals to 0 means not buy. Okay, and here my independent variable x is the age of the customer.
Mm-hmm.
Okay, so now here I have this 0 1. So y is either 0 or 1. And here I have these data points. Okay, so let me just write these data points. So here I have different data points. Let's say I have few data points here and few data points here. Okay, that means what? So if I look into my data set here, so here I have my x variable, which is my age, and then my y column. Okay, so x column and y column. So y
Mm-hmm.
is either 1 or 0. Okay, so here I'll have 1 and 0 like this. So this is a numeric value, age, or you can say it's continuous. Okay, x, which represents age, and y. So here my curve will look something like this.
Right.
Right.
Mm-hmm.
So this is my sigmoid function. Now, based on my logistic regression model, okay, so if I look into this sigmoid function, so this function is actually giving me this probability P, right?
Yeah,
So
exactly.
probability of occurrence of the event Y. Okay. So now here what I can get, let's say, so here I'll get this probability column based on my logistic regression model. So here if I just uh, give this P, which is this probability of Y equals to 1. Okay, so here I'll get probability values, which will lie between 0 and 1.
Mm-hmm.
Okay, so here what may happen is that if my probability value is very high, okay, let's say probability value of let's say 0.9, okay,
Right.
then that means what? My
That
logistic regression
it's
is
close to
predicting,
one.
It's close to
Yeah.
1. That means
Mhm.
here my logistic regression model is telling that the customer will buy that particular magazine. So y equals to 1.
Mhm.
Okay. So that means if it is close to 1, then I will say that yes, my logistic regression model is trying to predict that the customer will buy that magazine. If it is close to 0, let's say zero point 0.2 for example, then it's highly unlikely that
Yeah.
my customer will buy that magazine according to my logistic regression model. Okay,
Mhm.
so that I can say. Now, what about some other values? Let's say here if I get this probability value of let's say zero point 0.6. So what decision I will take?
It will be closer to 1, so uh, yeah, most probably they will buy.
Okay, so here what we will do is this. So this part is clear, I think, that
Yeah.
yeah, when there is a high probability, then we will try to predict that. So we can say that it is highly likely that my logistic regression model is telling that the customer will buy that magazine. And if the probability value is low, then I can say that it is highly unlikely that the customer will buy that particular magazine. Okay.
Right.
So here what we will do is that we will take some threshold for this classification purpose based on this probability column.
Mhm.
Okay. That means we will classify whether that customer will buy that magazine or not buy that magazine based on some threshold value.
Okay.
Okay. So here if I have this uh, probability value, let's say zero point 0.8, zero point 0.6, zero point 0.4, zero point 0.5, okay, zero point 0.2, let's say, and then zero point 0.7, something like this. Okay.
Mhm.
Then normally, okay, we will start with this threshold of 50% or zero point 0.5.
Mhm.
Okay. That means if my probability value is greater than zero point 0.5, okay. So if my probability value is greater than zero point 0.5, greater than equal to zero point 0.5, then y hat equals to 1. That means
Exactly.
y hat means predicted y value. Okay.
Mhm.
And if p is less than zero point 0.5, then y hat is equal to 0.
Mhm. Right.
Okay. So based on this, I can create this y hat column. Okay. Now, yesterday you were telling like I was having this probably y column here as 1 and 0, right? And then
Mhm.
this probability column, okay, obtained from this logistic regression model. So here I will not actually take this difference, okay, because this is a probability column, okay, and here this y is categorical in nature,
Mhm.
okay.
Yeah.
So
Makes
here y is specifically 0 or 1, but
Mhm.
here I have this range from 0 to 1, right?
Yeah.
Something like this. So here I have this specific value. So I'll not do that. Okay. So here, based on this threshold value, I will be able to calculate this y hat column. So 1.8 means 1, zero point 0.6 greater than 0.5, 1, 0. This one will also be 1 greater than equals to 0.5, 0, and then 1.
Mhm.
Something like this. Okay. Now, based on this data set, okay, or I'll change this data set. Okay. Now let's say I take some data set here where I have my actual y, I have this probability column, and then I have the y hat column.
Mhm.
Okay. So here, let's say I'm having 1, 1, 1, and then 0. Here, this probability column, so let's say this value only 0.8, 0.6, 0.4, 0.5, 0.2, let's say 0.1 and zero point 0.7. Here I'm using this threshold value as 0.5. Okay.
Right.
So here I'm just writing it as 0.5. So based on this threshold value, I will create this predicted Y column. So
Mm-hmm.
1, 1, 0, 1, 0, 0, 1.
Mm-hmm.
Okay. Now, based on this data set, okay, now I will talk about the different metrics. Okay, so I'll discuss about different metrics which are used to judge the discrimination ability of my logistic regression model. That means
Okay.
which are used to judge the performance, I can say. Okay, so performance of my model, logistic regression model.
May I ask,
Ask.
like, uh, so if we raise the threshold, for instance, from 50% to 70%, then can we say that our like
Yes, you can say.
probability is like more significant or something?
No, not as such. Probability is significant, but yes. So uh, initially, so as I said, that here I am taking this threshold value as 0.5,
Mm-hmm.
but this is not the exact threshold value that we will select. Okay.
Okay, cool.
So
Yeah.
here, yes. So if we raise this threshold value or decrease this threshold value, then this y hat column will change, right?
Mm-hmm. Yes, of course. Yeah.
This y hat column will change, and then this whole scenario will be different. Okay, so this is not some fixed value that we are choosing. So for the
Mm-hmm.
time being, let's say I choose this threshold value as 0.5.
Mm-hmm.
Okay, so I'll come back to this threshold value after some time.
Okay, sure.
Okay, so coming to the different metrics which are used to judge the performance of the logistic regression model. That means how good is my logistic regression model in discriminating, I can say the good and the bad observations. So good means you can say y equals to 1, bad means y equal to 0. Anything, something like this. Okay. Now here, so first, here so just like the type 1 error and type 2 error, we have created a 2 cross 2 table. So here also we will construct a similar table. Okay. So here I have my actual values in my rows. Okay. Where I have these two rows. So y, actually y is positive or true. That means y equals to 1, or y is negative or
Mm-hmm.
false. Okay. So y equals to 1 means I can say true or positive or good. Y equal to 0 means false or negative or bad.
Mm-hmm.
Okay. So something like this. So here what we will do is this. Here I'll just create this table here. So actually y is true, actually y is false. And then in the columns I have predicted y value. So predicted by my logistic regression model. So y is good and y is bad, or y is positive and y is negative. Okay.
Mm-hmm.
So here I will get these 4 cells here. Okay. So here actually y is positive. I'm predicting y as positive. So correct decision here. So true positive. Actually y is negative. I'm predicting it as negative, so true, negative.
Mm-hmm.
Here actually y is positive, predicting it as negative, so falsely predicting it as negative, so false negative, and here false positive. Okay, so actually y is negative, predicting it as positive. So
Right.
true positive, true negative, false positive, and false negative. Okay. Now coming to the different metrics here. Okay. So first we will discuss about accuracy. Okay. So what is this accuracy? This is the proportion of correctly classified observations. Okay. So proportion of observations that are correctly classified.
Okay.
Okay. That means here I am taking a ratio here. That means out of total number of observations or total number of classifications, how many are correctly classified. So in the denominator, I will have all these cells here. So true positive, true negative, false positive, false negative. Okay. And how many are correctly classified? So
It's true positive and true negative.
true negative. Okay. So true positive and true negative. So total number of observations. Here, correctly classified observations. Okay. Now coming to the other metric, which is sensitivity. Okay. So what is the sensitivity? Sensitivity is also known as the true positive rate. Okay.
Right.
So true positive rate, also known as recall. Okay.
Mm-hmm.
That means out of actual positive, how many are predicted as positive? Okay. So out of actual positive, how many are predicted as positive? So actual positive means this one. So true positive plus false negative. How many are predicted as positive? That is y equals to 1 out of this actual positive. So true positive.
True positive. Oh, okay. Yeah.
Okay. So this is about this sensitivity. Now coming to the other metrics here. Now we have specificity, also known as true negative rate.
True negative. Right. Ah, okay.
Okay, just the opposite. So
Yeah. Makes
truly
sense.
predicting it as negative. Okay, that
Mm-hmm.
means out of actual negative,
Right.
how many are predicted as negative?
Mm-hmm.
So true negative, so actually y equal to 0. That means false positive plus true negative. Okay. And how many are predicted as negative? So true negative.
Mhm.
Okay. So accuracy, sensitivity, specificity. Now coming to precision. So precision is known as, I can say, positive predictive value.
Okay.
That means out of predicted positive, how many are actually positive? Okay.
Mhm.
That means predicted as, so I can say predicted positive. So out of predicted positive, how many are actual positive? Actually positive. So predicted positive means predicted y equals to 1. That means true positive plus false positive.
Right.
So true positive plus false positive. Out of that, how many are actually positive? So true positive.
Mhm.
Okay. And then we have something known as F1 score, which is the weighted harmonic mean of this precision and recall. Recall means sensitivity, that is true positive rate. Okay. So weighted harmonic mean of precision and recall. So here I'll just write this. So 2 times precision recall. So weighted harmonic mean, so precision plus recall. Okay. Now coming to these metrics now. Okay. So here I'm having this sensitivity. So true positive upon true positive plus false negative. Specificity, true negative plus false positive. And here I have true negative. Precision, true positive plus false positive in the denominator and true positive. Yeah. And then I have this accuracy. So actually accuracy will come at the top. Okay. Let me
Mhm.
write it later. So and then I have this F1 score. So weighted harmonic mean of precision and recall.
F1 score.
And here I have this accuracy, negative. Here I have true positive, true negative, false positive, false negative. Okay. Now here, when I am looking into this accuracy, so accuracy will give me the correctly classified observations. So proportion of observations which are correctly classified. Okay. So now here, if I look into this formula, so here I have this false positive and false negative in the denominator. Okay. So here, so this matrix is known as the confusion matrix.
Fusion matrix. Okay.
Okay. So confusion matrix. So here I have this false positive and false negative in the denominator. Okay. So here, if the number of observations in this false positive and false negative is not that different, that means if they are more or less balanced, okay, then this accuracy will be a good metric. Okay, so I'll come to examples also. Okay, so if, so I'm just repeating this. So if there is not much difference between this false positive and false negative, then this accuracy will be a good metric. Because if there is a large difference between this false positive and false negative, okay, then this accuracy will not be able to identify that difference.
Right.
Right.
Yeah.
That means if I have an imbalanced data, okay, so that type of data is known as an imbalanced data, where there is a large difference between y equal to 1. So number of observations in y equal to 1 and number of observations in y equal to 0. Okay, so there is a large difference between this number of observations in y equal to 1 and number of observations in y equal to 0. Okay, so if that is the case, this accuracy will not be able to identify that difference.
Right. Okay. Interesting.
Okay, so here I can just write it beside this only. So I can say that accuracy is a good measure if we have a balanced data set.
And in F1 score, the R is for recall, right?
R is for recall.
sensitivity.
Yes.
Okay.
Okay. Now, coming to the sensitivity or true positive rate. Okay. So here I have false negative. So if false negative plays an important role, that means if in my data set I have a large number of false negative, okay, then that will be identified by this metric sensitivity.
Yeah.
Okay. So if false negative plays an important role, okay, then we use
We will see it.
sensitivity or recall. Okay.
Right.
Or recall. Right. Recall. Specificity or true negative rate. Okay, so this is not that important. I'll come to this one. So here I have false positive in the denominator. So if false positive plays an important role, then we use specificity.
Mm-hmm. Or precision.
Okay, now coming to precision, positive predictive value. So here I have false positive. Okay, so if false positive plays an important role, we use precision. Okay, and F1 score means if both precision and recall. Okay, that means precision and this sensitivity or recall plays an important role. That means if false positive and false negative both plays an important role,
Mm-hmm.
then we go for this F1 score. Okay, both is an important role. We use F1 score.
Right.
Okay. Okay, this part let me remove. I'll come to this part. Now, let's take an example here. Let's say that mm, okay, let's take a okay. Let's say that here I want to predict like so positive means so I'm talking about let's say corona. Okay, so here I'll just take this example. Let's say that I want to identify how my corona toolkit, okay, is identifying patients with corona. Okay,
Mm-hmm.
so here let's say y equals to 1 means that the person is having corona.
Right.
Okay, y equal to 0 means that the person is not having corona.
Mm-hmm.
Okay, so here coming to this confusion matrix. So actual y equal to 1, y equal to 0 and predicted y equals to 1, y equal to 0.
Mm-hmm.
Okay, so true positive, true negative, false negative, false positive. Okay. Now let's say here I have this set of observations here. Let's say I have 20 here. Okay. 20 in true positive, 40 in true negative.
Mm-hmm.
Okay. And let's say 60 false positive and 0 in false negative. Okay.
Okay, well.
Let's say. Now here when I'm computing this accuracy, okay, so accuracy means I'll take the summation of all this. So 60 plus, so 20 plus 40 plus 60.
Okay.
Okay, plus 0 also I'll just write here. And in the numerator, I have true positive and true negative. So 20 plus 40.
Okay, so it's 50%. Nice.
Okay, so 50%. That means 0.5. Okay, accuracy. Now, here, if I calculate this sensitivity or true positive rate, okay, that means out of actual true, so 20 plus 0, how many are predicted as true? So 20. That means 1. Just let me check true positive, true negative. I think, okay. Let me change it. No, this will not work. Let me change this to true negative. Yeah, sorry, I just made a mistake. So here, okay, so here I am, so out of actual positive, so 20 plus 60, okay, how many are predicted as positive? So 20, okay, so 20 upon 80, that is 25%, right?
25%. Okay.
Okay, so 0.25, that is 50% here, 25%, specificity or true negative rate. So out of actual negative, so 0 plus 40 here. How many are predicted as negative? 40.
Awesome.
1. 100%. Precision, that means out of predicted positive, so 20 plus 0 here. How many are actual positive? So 20. Okay. So here, if I try to analyze this, so what it is trying to predict, so accuracy means how many are correctly classified. That means out of 100 individuals, okay, so if I have 100 individuals, so out of 100 individuals, 50 are correctly classified,
Right.
right? That means patients who are actually having corona are predicted as corona, and patients who are not having corona are predicted as not having corona by my corona toolkit. So accuracy is 50%. But here there is a large difference. So false positive is 0. Okay. So false positive is 0, whereas false negative is 60. Okay. That means here I have a, an imbalanced data here. Okay. So here this accuracy is not able to identify this difference between false positive and false negative. Okay. Now coming to this sensitivity part, that means true positive rate. That means out of, so the patients who are actually having corona, okay, so out of patients who are actually having corona, how many are predicted as having corona by my corona toolkit?
Right.
Right. So that is only 25%. Okay. So this is an important metric for this scenario. Right. So what
Yeah.
we want this sensitivity to be higher.
Yeah, sure.
Yeah. Now here specificity doesn't play an important role, because that means what? True negative rate. That means out of, so out of patients who do not have corona, how many are predicted as not having corona by my corona toolkit? Okay, not that important here.
Mm-hmm.
Okay. So this is how actually we need to identify the different metrics.
Right.